we have got a center. It's a clue that we might need to use one of the center theorems, but not theorem 1, because theorem 1 does not involve angles. By now you should have seen that. If you are studying hard, you should have seen that, okay, theorem 1 does not involve angles. It involves lengths. Okay? So either theorem 2, angle at center is 2 times angle at circumference. Or theorem 3, an angle subtended by a diameter is 90 degrees, the shortcut angle in a semicircle. Or theorem 4, angles in the same segment. Any one of those three. Together with your grade 10 knowledge, your grade 9 knowledge, your grade 8 knowledge. Okay? Remember, you have done geometry in 3 grades now. So all of the concepts you have learned, grade 8, grade 9, grade 10, you need them. Geometry of straight lines, geometry of triangles, you need that. Quadrilaterals, you need that. Okay? So we are given that ABE is equal to AC. So that AB is equal to AC, and then B1 is 31 degrees. Okay? That information is given. It's on the diagram as well. So the first question says, determine with reason the size of O1. Okay? Now, O1 is this angle here. It's a reflex angle. Okay? Remember, I told you that at the center, there will be 2 angles. There is the first case where you can have an acute and a reflex. Sometimes you can have an obtuse and a reflex. Okay? This case here is most likely that you might have an obtuse and a reflex. Okay? So O1 is greater than O2. Okay? Based on theorem 2, to get O1, I need to calculate what is the angle A. Because angle A is half of O1. Okay? Based on the lesson that I did last Thursday, the different scenarios with regard to theorem 2. So angle O1 is 2 times angle A. Now, for this question, you have to calculate the value of angle A first before you calculate O1. Okay? So, if you were to be writing a test, the first thing, identify the triangle ABC. Okay? In triangle ABC, AB is equal to AC, and this is given. Okay? Because of this, we can say angle C, I think that's C1. Angle C1 is equal to angle B1. They are both equal to 31 degrees. Okay? Your reason is not isosceles triangle. It's angles opposite equal sides. Angles opposite equal sides. So that's angles opposite equal sides. Okay? Not isosceles triangle. Okay? Then from here now, we now know that C1 is 31 degrees. Okay? Obviously, it's now easy to calculate angle what? Angle A. Okay? So this angle here, C1 is 31, you need to calculate that. Right? So from here, you can say angle A, because C1 is equal to B1, I can write this as 180 degrees minus 2B1. Okay? Right? Because if you add angle B1 plus C1 plus angle A, you get 180 degrees. But C1 is equal to B1. So when there is B1, I can put C1 there. Right? I think to avoid problems. Right? Avoid problems. Because I realize I don't have to assume that people are understanding. So what we can do, we go back to the basics. Angle A plus angle B1 plus angle C1, this is equal to 180 degrees. Then your reason, sum of angles in a triangle. Okay, I'm going back to the basics there. Okay? But B1 is equal to C1. Okay? So both are equal to 31. So what that means is that angle A will be equal to 180 degrees minus 2 times 31. So this will give me 180 degrees minus 62. Okay? And that will give me 118 degrees. Okay? Yeah. If you try the question, this is the opportunity to ask questions. Okay? This is the opportunity to ask questions. Then, but we have got a question there. Yes. Okay. Please be aware that you cannot get O1 without getting angle A first. So, all this working out up to there is to calculate A first. Then, after getting angle A, you can then now say angle A is half of angle O1 because it's an angle at the circumference. Therefore, it's a half of O1. Yes. But before you get to say what is the value of O1, you need to get A first. And this is the working out. There is no way, okay, for this question here, there is no way that, well, as it is, there is no way that you can just get the value of O1 so easily without a working out, based on the information that's provided. You have to go via this route to calculate A. Right? Then, from here we now say angle O1 is equal to 2 times A. Why? Because of theorem 2. Angle at center is equal to 2 times angle at circumference. Over the past days, you should be seeing the 4 theorems. Line from center perpendicular to a chord bisects the chord. Line from center to midpoint of chord is perpendicular to a chord. That's the theorem 1 and the converse. Theorem 2, angle at center is 2 times angle at the circumference. Theorem 3, an angle subtended by a diameter is equal to 90 degrees or angle in a semicircle. Theorem 4, angles in the same segment. Right? Those are the 4 center theorems. The 4th theorem, it also falls under what are called cyclic paths, which I asked you to copy down on Friday. Right? So angle O1 is equal to 2 times 118 degrees. Then this will give you 236. Okay? So angle O1 is a reflex angle. Okay? It's a reflex angle. Alright? Now, can you see straight? Your body language is important. I'm sure you can see that everything I wrote here, whenever I wrote a statement, I gave a reason. Okay? That's what I expect from all of you. Whenever I write a statement, there has to be a reason why you are writing that statement. Don't keep things in the head. You write it down. Okay, so if this question had 4 or 5 marks, you do everything like how I did it, you get your full marks. Okay, and you can challenge anyone that what you wrote is 100% correct. Alright, so that's O1. Then let's go on to B2. Is there anybody who has got a question before I move on? Alright, then B2, this angle here. Okay? Now, to calculate B2, obviously, you should be aware that OB is a radius, OC is a radius, which means triangle BOC is isosceles, but we don't give our reason as isosceles triangle, right? So you need to know how to approach that. So, this is how you should do it. First thing, you must write that OB is equal to OC and give a reason that they are radii. Okay? So this is number 2 now. So we say OB is equal to OC, and they are radii of a circle. Okay? Now, how does that help me to calculate V2? It's very important, right? Then the next thing now is I'm going to calculate O2. Okay? I'll calculate O2. So O1 plus O2, they add up to 360 degrees. And please, these are angles around a point. I'll give you the full page of the reasons. I need to make a copy of it so that you can paste it in the next one. I think by tomorrow. Right? But I can send you the e-copy of it today with some resources on geometry as well. Right? So we know that O1 is 236, therefore O2 is going to be 360 degrees minus 236 degrees. And this gives you 124 degrees. Okay? Alright? So I found the value of O2, which is also at the center. Okay? Then the next thing now is to use your knowledge of geometry of triangles. The sum of angles in a triangle add up to what? 180 degrees. So C2 plus C3 plus O2, that will give you 180. So it's going to be, let me identify the triangle first. So say in triangle, okay, forget about the spacing, but I can write BOC here. In triangle BOC, right? Angle O2 plus B2 plus C2, they give me 180 degrees. And the reason is going to be sum of angles in a triangle. Okay? But we want B2. We don't know what C2 is. Right? But, right there, but B2 is equal to C2. Okay? The reason why these two are equal is because of what I wrote here at the beginning. It's because of this. Right? So, my reason will be angles opposite equal sides. Okay? Once I've got this statement B2 equal to C2, it means I can replace the C2 by B2 because they are equal using your knowledge of equations. So, therefore, O2, okay, let me just substitute my O2 there. O2 is 124 degrees plus 2B2. Okay, this is equal to 180 degrees. Okay, then you subtract 124 from 180, so you get 2B2 is equal to 180 minus that, you get 56 degrees. Therefore, therefore, B2 is going to be 28. And then you're done. Okay, it's easy. It's easy. Everything starts here. All right? Okay. If you want to show that you really know your stuff, if you are working with triangles, identify the triangle, name the triangle. Okay? There is no mark allocated for this, but it shows that you know what you are doing. Okay? And it also makes things easier for whoever is marking your work that, okay, this child has specified the name of the triangle. You go to the triangle and look at what you are doing. Okay? And I'm sure you can see that I'm showing everything, the statements, the reasons. And you need to make sure that when you're answering questions like this here, provide more information than less information. Okay? If you provide less information, you can end up losing some marks. Any question? All right, then let's move on. Let's move on to the next question. Right, now we are doing question E now. So in that sketch, again, there is a center, okay? The moment you see the word center or you see a diagram with a center, you must think about the center theorems, okay? You must think about the center theorems. Then we are given that that angle there is 110, AC is equal to BC, okay? So we've got AC equal to BC. So we need to calculate A1. Now A1 is this angle here. That's A1, right? Now to calculate A1, based on this diagram here, okay, it will be better for you to calculate B1 first, okay? Now if you're paying attention last week, I did different types of questions on Theorem 2, okay? So we have an angle at the center, which is subtended by chord AD. The chord is not drawn, but it does exist, okay? Because point D and point A are at the circumference. So we can do a construction here of a chord AD. That chord subtends angle B at the circumference. So it means B1 is half of AOD. B1 is half of AOD. Because they are angles subtended by the same chord at the center and at the circumference. Okay, if you've got your page, you can turn it around so that you can see it properly. Sometimes when you're answering geometry question, you might need to turn the page around so that you can see it properly. Because as it is here, it might be difficult for you to see that you need Theorem 2. Okay? Yes, don't be scared of the question paper. Okay, so for E1, first thing that I'm going to write is to say AC is equal to BC. This is given. There's a reason why I need this. Okay? AC is equal to what? To BC. Then I'll say B1 is equal to half of angle O. Well, please allow me to just maybe call it O1 and then the reflex, I'll call it O2. You are allowed to do that. That's why when you write a geometry test, you might get a diagram sheet where you can write some stuff there. Okay, you are allowed to do that. So either I can call it reflex, I can call it obtuse A or D. Okay, let me call it obtuse A or D for now. But this is also correct. I can call it O1 and that one O2. As long as you indicate on your diagram. So I would say half times obtuse A or D. So there are two angles there that are both the same name, A or D. But if I write obtuse, it means I'm distinguishing between the two. A or D that I want is 110 degrees. That's an obtuse angle. Right? Then the reason angle at center is equal to 2 times angle at circumference. Angle at center is equal to 2 times angle at circumference. Okay? Then B1 will be equal to half times 110 degrees. That will give you 55. So I'm not done. I only found B1. Okay? But B1 is going to be equal to B2. Okay? But B1, okay, I'll say A1 is equal to B1. They are both equal to 55 degrees. Why am I saying that? Because they are angles opposite equal sign. Are you following there? A1 is equal to B1. They are both equal to 55 because they are angles opposite equal sides. And which sides are opposite those two angles? It's AC and what? AC. Okay? And then you do something like this, then you are guaranteed. Okay, so I've done the first one. Now the second question, okay, is there anyone who's got any question before I move on to the next one? Any question? So the second question, show that AB is parallel to DE. Okay, I can assure you that this question will cause lots of problems. But it's probably one of the easiest. Yes. Now, if you want to prove that two lines are parallel, first thing, think about your geometry of straight lines. Alternate angles that are equal, corresponding angles that are equal, co-interior angles that add up to 180. Okay? Furthermore, midpoint theorem that you did last year. Okay? Your midpoint theorem that you did last year. Right. But for this question here, we don't need the midpoint theorem. Okay? We don't need the midpoint theorem. But there are some questions that you need it. Okay? So here, I just have to prove that either angles are equal because they are alternate, or they are equal because they are corresponding. Okay? I'm not sure how you did, but some of you I saw that you had an idea. But in my case, what I'm going to do is, I'm just going to prove that B1 is equal to BDE. That's all. I'm just going to prove that they are equal. I know that angle B1 is 55. So all I have to do is prove that BDE is also what? 55. That's all. Once you prove that BDE is 55, you should start smiling. No need for an increase in heartbeat. Okay? All right? Okay? That's one way. Listen, that's one way, right? I can also prove that this angle here is equal to that whole angle. Well, you see A1. A1 and this whole angle here, they are equal based on theorem 4. Do you see that? You are not going over your stuff, I'm sorry, things are going to become tough. Right? Right. Do you remember when I told you about the butterfly? I think it was last week. Okay, let's identify the butterfly. So if you look at this diagram, we have got a butterfly here. Right? That's a butterfly. That's a butterfly there. Okay? So all I have to do is just to say A1 is equal to that, which means this is 55. Since this is 55 and that's 55, then I'll say B1 is equal to BDE. Therefore, AB is parallel to DE. Then I'll give my reason as alternate angles being equal. And then I'm done. Okay? Okay, so let's do that. Let's do that. So first thing it is to calculate the size of BDE. That's the first thing. So BDE is equal to A1. Okay? BDE is equal to A1. So this is E2. So E2, you must say angle A1 is equal to BDE. And the reason that I can put the angle there, which is equal to 55 degrees. My angle is angles in the same segment. Okay? How did I identify the angles in the same segment? The butterfly. I've got I've got 4 vertices on the circumference. 1, 2, 3, 4. Okay. It also means that I've got a cyclic quad, which is what I'll talk about later. Remember, I said theorem 4 is part of the center theorems. It is also used under cyclic quads. The converse is used to prove that a quadrilateral is cyclic. Okay? Then, once we have got this, then we say, therefore, B1 is equal to BDE. And they are both equal to what? 55. Right? Therefore, AB is parallel to DE. Why? Because they are alternate angles that are equal. Then we are done. Okay.